Welcome to today's podcast episode. We're diving into the fascinating world of programming languages, focusing on a relatively new and experimental tool, JAWS. Now, you might be asking, what exactly is JAWS? Well, it's a compiler that turns JavaScript into WebAssembly, and it was written in Rust. But what makes it truly interesting is its unique approach to compiling JavaScript, putting it in the same realm as a tool called Porfor, yet doing things a bit differently. To give you a little backstory, our host has been working on a project called Crows, which is all about stress testing scenarios in WebAssembly. The idea behind JAWS came from the realization that while Rust is a fantastic language, it's not exactly popular among everyone. Plus, there's a challenge when it comes to running scripts from languages like JavaScript on top of WebAssembly. You either end up with a heavy interpreter or need to shift to lightweight variants of those languages, which can be quite limiting. So, the big vision? Our host believes that with the latest and greatest from WebAssembly proposals, it's possible to fully implement JavaScript features without relying on compiled interpreters. That's pretty groundbreaking. Now let's break down some of the components of JAWS. The goal is to eventually support 100% of JavaScript, but as it stands, many language features and built-in types are still a work in progress. It's kind of like building a house. You have to lay the foundation before you can start decorating. The initial focus is on implementing fundamental semantics, like scopes, closures, and error handling, before diving into all the grammar and built-ins. Speaking of challenges, there are 4 significant hurdles that our host is tackling. Scopes and closures, try-catch blocks, async await, and generators. The interesting part is that by getting generators to work, it also gives us the tools to make async await operational. So far, JAWS can handle closures, can throw errors in asynchronous functions, and even has some support for promises. Let's take a moment to visualize how all of this works. Imagine a simple JavaScript function looking for a variable in its environment. JAWS translates this into WebAssembly instructions, ensuring that when that function is looking for our variable, it knows exactly where to find it in the scoped structure. It's like teaching a new intern where the files are in a messy office. However, things aren't perfect just yet. The binaries that JAWS produces aren't universally portable between different runtimes. The current development scenario involves using V8 through Node.js, essentially acting as a bridge until full compatibility with standards catches up. This setup means that if you wanted to try it out yourself, you'd need to clone the repository, run a few scripts, and you guessed it, make sure you have some modern tools at your disposal. What's next for JAWS? The roadmap is clear. Finish the challenging features like those pesky generators and async await support before gradually implementing everything else, such as grammar constructs and built-in types. To sum it all up, the journey of building JAWS is not just about creating a JavaScript WASM compiler. It's an exploration of what's possible with WebAssembly, pushing the boundaries of how we think about compiling languages. So if you're excited about the intersection of JavaScript and WebAssembly, or if you're a developer looking for new opportunities, keep an eye on this project. Before we wrap up, here's a thought-provoking question. How do you think the evolution of tools like JAWS will change the way we think about programming languages in the future? Thanks for tuning in today, and be sure to join us next time for more on the latest innovations in programming and technology.